Hey everyone. So for today, the assignment was to try to solve this little puzzle that I made for you guys. So the first thing you want to do is load in the zigzag.txt file, which I shared on Schoology. And I want you guys to give this a try, um, first and foremost. So I'm going to explain how to do it, and then what I want you to do is pause the video, um, try and figure out how to do it. And then, after you give it an honest attempt, maybe you get it, maybe you don't. I want you to look at my sample solution to see how I would have done it. And I'm going to go through that with you in the video. But let me first explain what the puzzle is. So you're going to download this zigzag.txt file and then just drag it into your project so that it shows up in your package explorer. And you're going to change the map name to zigzag.txt. I got rid of any of the functions that we're calling here. And so we can run this, we can see that this is what the map looks like. And it's just this little zigzag here. And so what I want you to try to do is I would like you to try to write code that will have Carl move all the way through this zigzag pattern, making all of the squares light. All right. And I want you to try to do this in maybe as functional as possible, if that makes sense. What I mean by that is try and find patterns. See if you can see a pattern, and see if you can, use that pattern to solve the said puzzle. And so go ahead, pause the video right now. Work on this for a few minutes. See if take 10-15 minutes. And see if you can't write a function that will actually solve this. If you need a little bit of help getting started, you can start watching the video again. I'm gonna start going through my solution. But do try it on your own. Next week I'm going to be giving you guys some puzzles starting next week to kind of figure out on your own. And so give this one an honest attempt so you get the hang of it, and you can have questions for me that might come up. All right. So hopefully you were able to give that a try. And the first thing I'm going to do is I'm just going to call a function called solve zigzag, which we haven't written yet. So I'm going to have an error here. And then I'm going to go over to Carl and I'm going to write this function in here. So it'll be a public static void. And it'll be called solve zigzag using camel case. All right. And now I'm going to start thinking about how I want to solve this puzzle. And so one thing I notice here is when I'm looking at this is I can see a pattern that's repeated twice. It's almost like two little hooks. There's a hook here, and then there's another hook here. So if I can write the code to solve one of these, then I can repeat that code twice, and that will solve both of them. Another pattern I notice is that the dark squares here, so the goal is to make all the squares light. So the dark squares here are on the bottom and they're also on the second and fifth one of each one. So second, fifth, second, fifth, second, fifth. So it looks like if I start it off and get it to this point here, I can repeat code for one straight part, if that makes sense. So I can have a function that moves it upward, and then I can have a function that moves it leftward, and then I can kind of repeat that twice. Okay. And so I'm actually going to do something called creating a helper function. And what I mean by that is it's going to be a function that I call from within the solve zigzag function. And this helper function is going to be just for one of those zigzag, one of the, let me show you here. It's just going to be for one of these here, right here. So I'm going to, this is a straight part, whatever I might call that. Maybe that's a zig and that's a zag. We can do that. So maybe this one will be the solve zig function. And so this will be the horizontal part of the puzzle. And so if I'm looking at this, I'm going to assume that, Carl is starting facing, this direction, and he has to move through this like that. So he's just going to be moving forward 5 times. So I can just put in a for loop here to move this 5 times. Carl.move. All right, so that'll take care of just 1, 2, 3, 4, 5 moves. Now, after the first move and after the last move, I need to actually make the square dark. So there's a couple of different ways we can do this. We could try to make this, or sorry, make the square light. We could try to make the square light after every one and then put in an if statement to see if that square is already light. If it's already light, don't make it light. But if it's dark, make it light. Something like that. You could also just say like if I equals 0, that means this is the first time it moves. And if I equals 4, that would be like the last time it moves. So I'll show you a couple different solutions. But before we actually do this, let's actually write our other helper function, which is going to be solving the zag or this upper part here, so the vertical part. And again, if you didn't come up with helper functions, if you just put everything in one big method, you should probably have these components to it, but it might look a little bit more clustered. And so, hopefully this will show you, oh, okay, I can organize my code a little bit more into functions, and that'll help. Okay. So here I have I equals 0, I less than 2, I plus plus, because all I have to do is move twice. Now, here's the thing. If I take care of the making the square dark in the zig piece, then I don't need to worry about making the square dark except for this very first one. So you've kind of got you've got a little bit of a problem here in terms of parity. If we just make these two squares light in the zig method, then it'll work for this, and that. But it will never make this square dark because of it's our starting point. So we'll have to add in a make light before we do anything else. However, if I put the make light in the solve zag, then it will actually solve this one, and then I would only have to put one make light in the zig, and then we'd get alternating ones. But then I'm actually going to have to add a make light at the end. So it doesn't really matter how you do this. Just know that you're going to have one extra make light either at the beginning or end of your code. Right. So I'm going to choose to put them both in the zig and then put the extra make light at the beginning of my code, which I'm actually going to just add it right now before I forget. Okay. And so all the zag has to do is just move twice. So, you could write a for loop, or you could just type carl.move twice. But basically, this will be the vertical component. Okay, and so basically, we're going to make this first square light, and then we're going to start this pattern. We're going to first start by saying, hey, let's solve the vertical part. And then let's solve the horizontal part. Now, before we do that, though, we need to have the robot turn to the right. All right, and so let's test and see what we have so far. So we just got a series of movements. We make the square light, we solve the zag, we turn right, we solve the zig. And so now Carl will go through and he'll complete this first part. All right. Now I'm at the point where I can almost repeat this code. The only problem is that the direction that I'm turning here, I have to turn left and then I have to turn left again. But I don't have that anywhere in my code. All right, so I'm gonna have to turn left. Then I can do the solve zag again. And then I have to turn right. And this gets me basically back to the beginning. Sorry. Hold on. Let's see where that's at right now, actually. Okay, so turn right. Oops, okay. So we messed something up there. Let's see. Let's go through this again. So make light, solve zag, turn right, solve zig, turn left, solve zag. Oh, turn right. So I want to turn left. Sorry, I got ahead of myself here. I want to turn left and solve another zig, and then finally turn right. Okay. And now when I run my code, I see that I get, it going all the way through the maze. And now all I have to do is basically repeat my code, and this will get me up to this square here. And so what I'm going to do is I'm just going to add a for loop in here. And I'm just going to use curly brackets to encapsulate all this code here. Now, one thing you can do is like I want to make my code look nice. So one thing we worry about, you'll notice I've been doing is I've been tabbing in code inside the for loop. This just makes it easier to read. And so instead of like going through each of these lines and hitting tab and then going to the beginning of the line and hit tab, what you can do is you can highlight all of them and then hit tab then, and Eclipse will automatically tab them all in. If you want to undo the tab, then you can do shift tab and that'll untab them all. So you can tab multiple lines of code. But now when I run this, I'm almost done with it. I can see that Carl makes his way all the way through the zigging and the zagging. Notice I didn't include the make light in the loop here, and this makes sure that the pattern of the second and the fifth one each time are still there to make light. Okay, so now there's a couple things we could do. One easy solution to this during the zig is just to say like if Carl is on a dark square, then let's have him make it light. And that's a very simple way of saying every time he hits a dark square, let's just have him make it light. And here he'll go through and he has solved the zigzag. Like I said before, there's another way of doing this, so I'm going to comment this out. You might notice I can highlight these. What I'm hitting is Control and then the / or the question mark key. That'll comment and uncomment multiple lines of code when you have them highlighted. So another option we could do here is we could say if I equals 0 the first time he moves, or now there's no or in Java in terms of like the OR letters. You actually have to use the vertical lines, the double vertical lines. And we talked about these in Alice, but I haven't introduced them in Java. I did introduce the negation yesterday with exclamation point, and I'm going to actually go through these logical operators now and give you a list of them so you can have them to use. But this is logical OR. All right, so there's a couple logical operators that I want to show you. All right, the first one is this double ampersand. This is and. So if you want to check to see if both conditions are true, so if this is true and this is true, you would use double ampersand. In this case, we're using or. This is the double vertical line. It's the key next to enter. This is or. Check to see if either of the two conditions are true. So what I mean by that, in this case, we're using or because we want to see is I 0 or is I equal to 4. Now, think about what that looks like in terms of Carl here. All right. The first time I move, I equals 0. I move, I'm on a dark square. Okay. Then I is 1, I move. Then I is 2, I move. Then I is 3, I move. And then I is 4, and I move. So on the first move and then the last move, which is 0 and 4, I want to make a square dark. And again, since it's just one line, I don't need to put the curly brackets, but you could certainly include them if you want. And now, not make dark, make light. All right, and that's that's good. He'll go through the maze and he'll solve it. All right, what else? We have the exclamation point, which was not check to see if one condition is not true. So we talked about that yesterday. And those are your big three, and or not. And there's a couple other ones, but like there's an XOR one, but we won't worry about that one. You can look it up if you want to. XOR. It's exclusive or, but again, look that up if you would like to. It's a bitwise operator, so it's interesting. Has some applications. You'll probably learn about it in some more advanced classes. So we won't be needing it in this particular case. So all right. So I think that's most of what I wanted to show you. There's no other real good place to put this, so I'm gonna show you one more thing here, which is mod operator. This mod operator is something that you might want to use as well, and this is the percent sign, and this is modular division. We talked about this in Alice, and basically it's the remainder when you divide by a number. So normally when we divide, let's say we do 9 divided by 3, right? We say that the answer is 3. 9 divided by 3 is 3. The mod function, what that would do is that would say 9 divided by 3 is 3, but the remainder is 0. And so if we said 9 mod 3, the answer would be 0. It would be the remainder. So let's do another example that's a little bit more interesting, which would be 10 mod 3. Well, 10 divided by 3 is 3 1/3, or 3 remainder 1. And so 10 mod 3 would give us an answer of 1. So generally speaking, if you want things to repeat let's say I have a for loop that's going up to 20, let's say, and I want all the even numbers, then I could say if I mod 2 is 0. And that way, every time I gets to an even number, divide an even number by 2, you get a remainder of 0. If I wanted odd numbers, so for example, x mod 2 equals if x mod 2, so let's do the notation here, equals 0, then this is even numbers. If x mod 2 is 1, this is odd numbers. So this could come in handy with some of these exercises. And so I wanted to show it to you. It's not something that you need to use, but it's a pretty cool function that allows you to kind of write a little bit neater and more precise code. So there you have it. Again, you might have had all this kind of in one function. Generally speaking, I'd like you guys to try as much as possible in these exercises to kind of divide things up into functions, just like we did in Alice. Put it into a sub procedure. It makes your code cleaner. It makes it easier to debug when something goes wrong. And here we can kind of see our pattern and what it looks like. We've got 2 zigs, we've got 2 zags, with the turning left and turning right in between them. So, okay, so that's it for this video. Hopefully, you got a little bit of practice today, and you learned something. We're going to start with some exercises on Monday, similar to the one that we did today. I'll start them off with some easy ones, and progressively we'll get more challenging. So, all right, have a great weekend, everyone.